Hey, there you go.
Guys.
My name is Rick Button. Rick Button, KB4MIS, and I've been a ham since probably the early 80s. Got actually my ticket through this club. That's when I lived in Florida back in the 80s, and that was a lot of fun. But I got into amateur radio through a buddy of mine when I was a kid, helping him put an antenna up for his uncle, who was a real big ham radio operator. But that started the whole ball of wax. So I'm a tinkerer, and where I live, very restricted as far as the amount of property I have, and I rent, so I can't put anything permanent. So right now I'm operating off a vertical, and you know a vertical just isn't where it's at. It leaves a lot to be desired. So I started going on the internet, looking at different antennas. I was thinking about building a spider, thinking about building a hex beam. I just started looking at all kinds of antennas, and then I latched on to this thing, the Mag Loop. And the more I read, I was really just amazed at the quality of the antenna and what it can give you, but it has a lot of drawbacks as well, okay? So after I delved into the literature and started playing around with formulas, and all the calculators are online. So you can, you know, build a single frequency type of loop, one for like 80 meters or 10 meters or what have you. Or you can actually go into a little bit more where you can maybe get a couple bands, 2, 3 bands. I think there's commercial made that are multi-band. But I'm going to tell you, when you look at the commercial made antennas out there, if you want to drop $800, $900 for a loop, that's a little bit much for me. So I start, like I said, I'm a tinkerer, I'll start playing. And during COVID, couldn't do anything else, so you know, I've got some PVC, got some heliacs that I found from different places. Well, I'm going to try this. Now you can make this out of copper strap, you can make it out of heliacs, you can make it out of copper pipe, you know, just plain old plumber's pipe, all kinds of things. And you don't have to have it in a loop shape. It doesn't have to be a circle. Some of the designs, and unfortunately my computer doesn't go through there, but I had a bunch of pictures. They make them octagonal, there's rectangular, there's a loop on top of a loop. I mean, they just have really interesting designs, and they all do different things for you. So let me go into here. I wrote some notes, unlike me. So, having the restricted property, I thought, well, I really want something with some directionality as well. And this does have directionality, which is really pretty interesting. And if I were to take this and put it on a rotor, I'll be able to rotate it and be able to give it the directionality I want. These are extremely quiet antennas as well. So, when our noise level in Florida, or in St. Petersburg I should say, is like S9, this is going to hopefully help me hear those stations I don't hear now. Now this one here, it's been redone. I've redone it about 3 times. So I take it apart and redo it. And I've learned, actually, from Richie, I need to redo it again. For one thing, this is the Faraday loop. This is the primary loop. The Faraday loop actually picks up off of the primary loop. And my well, this one here is on the back, and it's tied to this. That also, this is very important as far as how close it is to this loop, the primary loop, and also the amount of surface area that it has interplay with. So I need to redesign that, but I need to take this and put it down here. It'll work better. Also, yeah.
You'll actually just flip the antenna.
Yeah, or just flip the antenna, and that wouldn't be hard either. Also, as I learned, and when you look at the literature look at all the different articles, they talk about different air variable capacitors and things like that. Apparently this is really the drawback. It does leave you with a lot to want as far as tuning. This actually is a better way to go. You go with the vacuum variable. Unfortunately, they're pretty expensive, but it will work better. And there's all kinds of mechanical drives you can make that'll tune it remotely, and that's the next project I have, is to figure out a remote tuning. And then this one here, I'm probably going to use on a larger antenna. Now, the problem with these, they're dangerous. There's a lot of voltage at the capacitor. And as Richie was saying, he had a dowel explode or burn up just for the amount of voltage that's there. So you really have to be very wary of that one point. Let me go back for a second here. I was looking just because, this thing here cost me, I don't know, maybe 40 bucks altogether. This I found. This was actually the most expensive piece. It was $17 at Home Depot, the enclosure. But PVC pipe I had laying around, and I just kind of put that stuff together. I got that cap at our last Hamfest, and it was like 2 or 3 bucks. But just for instance, on eBay, they have an experimenter's kit, and it was $160. Talking about prices. Another one that I saw, which was a 17 through 40 meter, was $285. So you can see these things are really expensive. But anyway, if you're into tinkering and you like doing this kind of stuff, this is definitely a way to go. So the big issue with these antennas is they're very, very narrow when it comes to the bandwidth, extremely narrow. So if I'm working, say, FT8 on 20 meters at 14074, and I get this tuned right to that, fine. But if I jump and say I want to go sideband to 14250 or whatever, forget it. It's totally out of tune. So the tuning is extremely sharp, and that's one of the big drawbacks of the antenna, unlike dipoles and so forth. The other thing is how much power you want to put into them. That's really important because your capacitor, if you use a capacitor, or if you use a trombone type of capacitor, which I've seen in YouTube videos where a guy built a trombone capacitor that literally adjusts, that can handle more power. But this here, this is going to arc, at 100 watts probably, if I put 100 watts in that. But I'm not a QRPer, but I rarely go much above 20, 30 watts. It's pretty effective. So I did get, this was in my garage, and I hooked it up to the rig. I got it to where I thought it was in tune, and then I looked at the SWR on my radio, because I didn't really have anything to measure. I got one now, thanks to Lisa. But I got it close to where I thought it was, and I was able to make contacts on it. So, but God forbid if I go over and touch it or get close to it, it's totally off again. So it's really a very temperamental antenna. I really like it because eventually when I get the antenna that I totally want to use day in and day out, I'm going to mount it in the back, and that'll become my primary antenna. And hopefully it'll give me, enough of the activity I want to get. So, there's some handouts I put out there on these loop antennas. The calculator, there's a couple of them. I think this one's called Pacific 66 or 66 Pacific. If you just type in mag loop calculator in the search engine, it'll give it to you. And then you can start fudging numbers here. You can start playing with things. And say you have a particular band that you really like to operate on, and you put that frequency in, and you start putting numbers in for like the circumference, how big it. It'll tell you, there's a little pop-up that'll tell you your loop is too small or your loop is too big. Because you can actually go beyond what the loop is supposed to be, and it becomes other than a loop antenna. So you just play around with it. And I mean, I have so many pieces of scratch paper with numbers scrawled all over. I mean, there's an example. So I just started playing with different frequencies and looking at what happens when I change the circumference, what happens with the dimension. Like this is 3/4 inch. I use 1/2 inch or this smaller diameter. I think this is 5/8. It's amazing how it changes. The other thing is with the loop is this here, the Faraday. You can use an approximation of 1/5 of this circumference is what this should be if you're going to use the Faraday. But like I said, I'm going to start experimenting with different means of matching and connecting my rig to it. So it's just one other thing that you can do to experiment if you like, you know, tinkering around in the garage and making up pieces and doing it rather inexpensively. As you can see, the big one here, I actually designed this so I could get on 40 meters. And it's not even done. I just kind of taped it up and stuck it together, but I already know I'm in for trouble because of this. It's mounted in the wrong place, so I'm going to have to do this. And that's all it'll take, you know. They're not very obtrusive if you're in an HOA. You know, you can stick it outside the door. Like I said, I had it in my garage, and very good reception. Unbelievable reception. Not even transmitting, just hooking it up to the transmitter and the receiver. Just listening, it's totally different from what my vertical sounds like, which is all static. So, what else can I tell you about it? That's pretty much it. Any questions, input, anyone else build them?
Your smaller loop there, which frequency band is that one built for?
This one here, I originally designed this for 10, and I was hoping to get 17 meters. And the interesting thing is, say I want a 3-foot diameter loop or something like that, right? It will then, once you start playing with it, it'll start showing you in the calculations how efficient it is. So if I made it, say, 3.5 foot, it might change really quickly as far as the efficiency for that frequency. So you just, depending on what you want to do and where you want to go with the frequency that you're going to use, that's kind of how you design your antenna. So if you sit on 10 meters a lot of guys are 10-meter operators, that would be perfect. If you're, 80 meter, you're looking at a whole different loop. I've seen also where there's people that make double loops. There's actually a loop and then another loop. And that's to give them, I guess, a little more advantage with 80 meters or even 160, I don't know. But there's so many different designs out there. I saw one today, I was playing on the computer. It actually was a piece of metal that was bent back and forth the whole circumference to increase the surface area. I don't know if it works, but I saw it and somebody's been playing with it, and I thought, well, that's pretty neat, I'm also thinking of taking just flat sheet copper and making it into a circle and seeing what that does. So the surface area of your primary loop is very important. So the smaller you go, the less efficiency, and it's not optimized. So if I were to take and double this thickness, I have a lot more surface area. I'm going to be able to play a lot more. Okay. I'm going to try some copper tubing, different things, and just play around until I find something that really is efficient and works for me.
How does the pattern come on? How does it radiate? Does it radiate
Oh.
broadside, or does it go like
Yeah.
two?
I had a
Straight down.
So, actually, the lobes, when you look at a dipole, now correct me if I'm wrong. If you look at a dipole goes up into the atmosphere, right? The lobes go up like that, is that right? Whereas this thing, they're lower lobes and they stretch out. So it radiates off the side. And you don't get the vertical height, so to speak. So the lobes, you reach further.
Is there a pretty big null when you turn it? Like if I don't want to hear what's coming from over there, if I turn it.
You know, I'm not sure of the answer to that. Anyone have?
So I got two of them, and I've done a lot of research to try to fix one of them, so I have a couple questions for you.
Okay.
Plus to answer what you've got going on here, is that the patterns are toroid. So it's a toroid around that. So there's two ways to use that. One is like he's got it mounted here where it's directional. It's directional in the path in the plane of the coils. And there's a very, very sharp null perpendicular to that plane. It's very sharp, and it's used for direction finding often in smaller loop designs. So to answer that, do you have any other questions before I
No.
take it?
Yeah, that's
So
great.
the question I have, here's a couple for you, for sure. One is that you said you're going to, when you get this all done, you're going to mount it. So my question is, are you going to mount it directionally, or are you going to mount it omnidirectional? Because if you rotate that, so the plane is horizontal, it's omnidirectional.
Right.
And one of them I have mounted in a room in the house, and it's omnidirectional the way I have it. The other one I have, which is portable, and for like QRP work, because the one in the house can take up to like 300 watts. Because it's got the big, large gap capacitor. It's the MFJ one I got from another club member. And then the one I have is more QRP, and that's the one I had to really work on to get it to work. And it uses like LN400 kind of, or 8U kind of a primary coil, and then the injection code is that small one. In my case, it's RG58. So, question for you is, make sure I get the correct with that. Have you found any different? First of all, do you have an antenna analyzer?
I just got it.
You just got it. So when you start experimenting with that,
Yeah.
okay, I'll be very interested to hear in the future about how that works for you. My experience is that, first of all, it's got a very high Q. That high Q is what makes it very quiet. The two go hand in hand. It's about 5 kilohertz bandwidth.
Yeah.
So it's enough for a single sideband, basically. And so you can receive either side of it, but you're receiving much lower signal level. So you can see if something's there, then you retune it. So basically, I tune to what I want to receive, and then I tune the radio, then I tune the antenna so I can pick it up, and all you do is listen to the background will spike. And then tweak that spike, and it's very sensitive. In my case, it's a single turn, geared capacitor. And then at that point, you tweak it again with SWR check, just to top it off. And mine's that portable one's good for 10 to 40 meters in that range. So what I discovered is, and you may discover this when you start working with this, is that the biggest problem I had is that it was unusable. And largely, if you're using it like in a portable kind of mode, it's just totally unusable, because what happens is that RF travels on the transmission line, on the coax, it travels as a way between the interconductor and the outside of the interconductor, let's say the RG58 that I'm using, and then on the inside of the outer conductor that it travels on it. And then when it hits that loop, is how it's should be properly constructed, is basically the interconductor goes and loops around and ties into the shield. And the shield is, ties into the main shield, and the shield, where it comes around, is not connected to anything. That creates the Faraday cage of the inner wire that's the loop. And what happens is that it hits that intersection and it can reflect off and then come back on the outside of the coax.
Right. Yeah.
Basically, so what I discovered is I needed to have an RF choke there.
Yep.
And because of the frequencies involved, all I did is took about 8 feet of an RG and then just looped it up in about a 4 or 5 inch loop diameter, and then had the connector on, and I just brought another coax and brought it up and kind of looped, get it away from the,
Right.
is what I kind
Yeah,
of did.
I didn't,
And I did that orthogonal, 90 degrees off of the plane of this.
Oh, okay.
Right at that injection loop, that a lot of people call it. And have you read the book from the, I think, Ukrainian guy it's like, it talks all about this stuff?
Oh, no.
You find it, and I think in ARL you can see it, find it there. So basically, when this comes up, is basically you need an RF choke right here.
Right.
Okay, tightly coupled, nice one, and then like right there, and I put mine orthogonal so it wouldn't couple. Even though, as you're right, the size of this and the spacing is absolutely critical to get the right ratio, so you get 500 ohms without reactive component. So you get a really, I get like a 1-to-1 SDR, really good. And because I've got this in here, my transmission line and my radio are not part of the antenna.
Right. Yeah.
And you're going to want to add that most likely, or some other methodology that creates an RF choke. I've seen professionals, they came up with like a little toroid thing, the transformer they put there. Well, however you end up doing it.
Yeah.
I don't know. Again, I'm not an expert, but I've studied this quite a bit to try to get my equipment to work. I got the capacitor box down at the bottom, I got this up the top, and it works fine. I don't know why you'd have to flip it, but you can't. I mean, there's no reason. Basically, I don't know, this is basically how I got the portable construction, except I've got that RF choke there.
Yeah, I think everybody has played around with them, and they're just all kinds of different designs, you know? Now,
It's the
as
fun
far
part
as,
of amateur radio,
Yeah.
playing around with it.
and as far as the RF choke, I do that on my coax, because
You want to get it right up to here.
But-
Anything above that is part of the antenna.
I got
And
you.
then it's part of your
So I
calculations.
want to build it
You want
inside
that-
this.
Well, inside or right at it.
Yeah, right.
Basically, I've got it constructed like right here. So this comes into a loop, and then at this point it taps off. So anything you do, this is now part of the antenna, and you have to consider
Right,
impact.
right. Yeah.
And that's what I discovered. Thank you
Okay.
very much. This is really cool stuff.
Yeah, it's a hobbyist tinkering toy. You know? I don't play with Lincoln logs anymore. I play with these. Okay. Oh, I thought you had your hand up. Who else had their hand up?
I did. Is it, could you use it just as a receive antenna, and would you use,
I think you can,
would you
yeah.
use a different size in that case?
I'm not sure.
No, it'd be the same.
It
So
probably
it's
has to do
tuned,
with whatever
that's what
band
you
you
receive
wanna
it.
use.
So, yes, you can, but but you tune it.
Yeah.
Because the narrowness is,
It's
the
a
narrowness
5
is
kilohertz, it's a 5 kilohertz bandwidth.
but it's narrow both on transmit and receive.
Yeah, it's the same. Because it'll be totally quiet off the band, and then what you'll do is turn that cap and go, and all of a sudden you hear background noise, and then you'll hear nothing. And
Yeah,
then you have to tune it.
Originally,
It's a little
when I-
wider on receive only.
When I built it, I didn't have any way to measure. So I would just tune this till I heard the loudest receive signal. And you're really not supposed to use your tuner in the radio, I read. But anyway, I did, and I was able to get it to a 1-to-1, but did it by audible. But every time I did it by audible, I'd come over here and I'd hear a spike, I'd walk away and they go down, and I'd come back over here and touch it. As soon as you get close to it, you change it. And so that was
That's the other thing. Now, do you happen to know, since you've been researching this, do you happen to know what the, actually, President Torrent, I can probably figure it out. Anyway, so one of the things we got to do is figure out power and figure out safety. And that is a real concern with anything over QRP levels.
Yeah.
Because I can tell you, having used my QRP antenna at 10 watts with a Raspberry Pi, I wanted to do digital modes like PSK 31, etc., with the Raspberry Pi and just a monitor plugged into it, I would cause the display to go out as I crank the power up. So as I crank the modulate, the amount of signal gain going into it, it would drop out because of the magnetic field that is produced nearby.
Yeah.
So if you're doing this as a QR, if you're going to be manually tuning this, like the one I got, the portable one, you're QRP, that's it.
Yeah.
If you want to put 100 watts into it, which you can make them so that they'll handle it, just like you said, like that portable one. Now you got to motorize it
Right,
because you can't be next to it.
yeah.
Well, you can tune the antenna to low power and then
And
when
then,
you step away, crank it
I
up.
don't know about you, but enough to do that anytime you want to change a spot, because that's a 5 kilohertz bandwidth you're retuning.
yeah,
Doesn't work.
I think the motorized unit is definitely the way to go, and I've been looking at all kinds of things with Raspberry Pi and what have you.
Well, just be
Yeah,
careful if the
eventually.
Raspberry Pi's anywhere near it. Be careful if
Don't
the
put it
Raspberry Pi's anywhere near it.
Yeah.
Go ahead.
Yeah, mentioning receiving, these loops are a godsend for folks that are stuck in condominiums or in nursing homes or who still want to maintain some sort of involvement in the hobby. I live in an S7, S9 environment where I am. Concrete tile roof, concrete block walls, and in the middle of the house, I use an AOR LA400, which is a commercial small receiving loop, and I can get DX, the 220 repeater, the 2 meter repeater. It's obviously up to your receiver, but I use an 8600 with it, and I can listen to 80 meter nets, 40 meter nets, no problem at all, and even DX inside the house with a small loop. It's about 12 inches in diameter, but it's an active, it's an active loop. I also do QRP with several commercial loops, and I really enjoy it. One thing you didn't mention was the ground loop. If you have a small backyard, you can use a wire in the grass, underneath the grass, in a loop fashion with a transformer, and feed it that way, and it makes a good receiving antenna. It's very quiet, and nobody will even know it's there.
Right, yeah.
A lot of fun.
Yeah, I know down the road I'm gonna try and build one for 6 meters, and that'll be a dedicated 6 meter loop, so. That, it's just something that you can really do a lot with and have fun doing it.
Yeah, I do want to say something,
Yeah.
okay? I've done a lot of work with loop antennas. In fact, way in the past, I was actually to the point where I was going to try to manufacture them commercially. The problem was that the company that was going to be supplying me with the vacuum variable went out of business, so that went south. You have to understand that these antennas, although they're small, these are full-size antennas. They're not compromised antennas. I don't know whether you would consider it a disadvantage. The narrow bandwidth of the antenna actually acts as a pre-filter to anything that you're listening to. So you may say, well, I'm going to have to retune the antenna. Yes. You have to retune this antenna just like you would have to retune a notch filter on your radio. So as far as size is concerned, in my experience, if you're going to build the antenna as a monoband antenna. As soon as you start trying to get into multiple bands, large bandwidth, it becomes a compromise. Rule of thumb, 10 feet, or I should say 1 foot per band. 10 meter band, 10 foot loop. 40 meter band, 40 foot loop. And that's the formula that I've always found to be most effective. Stay within those parameters. Now, the loop does not have to be completely round or what have you. In other words, if you want to do a 40 meter antenna, you can turn it into a rectangle, 5 feet by whatever. Yes, it will not perform as well as let's say a round or a square antenna, because the efficiency is determined by the area that the loop is handling. So for the most area per length or circumference, of course, will be a circle. But if you can't do that, a square or a rectangle or something like that will perform a heck of a lot better than anything else that you're going to be getting otherwise. So, narrowband is and also as far as safety is concerned, the antenna actually does have a safety factor built into it, because all the high voltages and what have you that are being generated are only being generated when the antenna is tuned. So as soon as you come close to the antenna and touch it, the antenna detunes itself. So all the radiation and voltages and currents and what have you nullify themselves. So as far as you're concerned, as far as getting close
Oh,
to
I'm
the
just
antenna.
operating it,
Yeah.
so if it's sitting on the table next to you, I wouldn't run it at 100 watts, you'd be making a
Well,
big mistake.
no, what's,
From a safety perspective.
you would not run any antenna that close to you at that power level. So
Of course.
the safety margins as far as RF is concerned
Well, we're actually,
would
we're
be
talking
for
about
any
magnetic
antenna.
field here, so really, if you close in, it's a magnetic antenna. It so
Well,
it creates a, it
it's
creates
an
an
RF,
intense
you're
magnetic field.
transmitting, you're generating RF.
Yeah,
So as far as the precautions are concerned, they're the same precautions that you would use for any antenna. And that's about it.
Any wrap up?
No, but I'll have some follow-up, maybe in another few meetings down the road, as to my redesign and changes to it.
Oh,
We'll
by the way,
see how it works.
if you put this antenna and you plot it on like Elnick or the antenna plotting program, you will find that having the capacitor at the top and the feed point at the bottom, regardless of what kind of feed point it is, you'll get the same height. You get a lower radiation.
Okay. Yeah, and that's the other thing, you don't have to get it high. You know, when you put a dipole up or anything like that, height really matters. With this thing can be actually down here. You know, the loop can be that low, half the diameter of that loop. It all needs to be off the ground. So, space-wise, we're looking at pretty nice.
Fantastic. February's Humber night. Bring the next thing with you.
February,
Not January, February.
putting the fire under me.
Go. Come on,
But
bring
you
it up.
gotta bring a radio and hook it up and make a contact.
I was gonna bring the radio, but I will. The next time we'll do that. I'll bring a radio and we'll hook it up and see how it plays.
All right,
Thank you very much.
thanks a lot.